So tell me what will be the value of n then? We have quarterly data 1958 to 1976 inclusive. So anyone? How many observations in that case we have?
19.
19 into 4, isn't it? Quarterly observations.
This one.
So it will be 19 into 4. So we have 76 observations. And this is the estimated model. Please write down the estimated model. YT is equal to 2.20. This Y is basically capital Y. So you can write capital Y. All Y and X are in capital. It is not in the deviation form, and you are finding the intercept is there. So the model is not in the deviation form. So capital YT is equal to 2.20 plus 0.104 x1t minus 3.48 x2t plus 0.34 x3t. Standard errors are in parentheses. So you have the standard errors 3.4, 0.005, 2.2 and 0.15. It is given that the explained sum of squares for this model is 109.6. So ESS is equal to 109.6. And RSS is equal to 18.48. 18.48. First part. First question A. Test the significance of each of the slope coefficients. Test the significance of each of the slope coefficients. So I hope you are understanding. For A, the null hypothesis will be, so please look at the right hand side. Please write down the null hypothesis. H naught colon beta 1 is equal to 0, beta 2 is equal to 0, and beta 3 is equal to 0. The null hypothesis is beta 1 is equal to 0, beta 2 is equal to 0, and beta 3 is equal to 0. How we will proceed for these tests? Anyone? How we will proceed? How we will proceed? Twinkle.
Yes, ma'am.
How we will proceed? Test the significance of each of the slope coefficients. How we will proceed? How we test the significance of a coefficient?
First, we have to write the H1.
H1, you know, in context of regression model, I mentioned that H1 is not that important. You know, you can consider not equal to test. I am telling you or asking you how you will proceed, how we will test the significance of the coefficient.
Ma'am, F test.
Why you think that you have to go for F test, Shreya?
Ma'am, because I have H naught which is I need to test that beta 2 equals to 0, like beta 1 equals to 0, beta 2 equals to 0. So all the
Individually, you need to test it. Test the significance of each of the slope coefficients. So individually, you need to test it.
okay.
Ma'am, the testing linear restriction parameter, that cases we will use.
Rudra, you wanted.
Ma'am, yes, ma'am. The intercept will be accepted.
Or you have
T-
to test for regression coefficients only, slope
yes,
coefficients only.
slope coefficients. The second slope coefficient will be means the means.
Tell me how we will proceed. Then I'll ask you the value. How
Ma'am,
will be the
ma'am,
test time?
we will write t equals to the value of the slope coefficient divided by the standard error.
So just simply tell us we will go for t-tests for each
Yes,
coefficients, isn't it?
yes, ma'am.
So we have to go for t-tests for each of the coefficients. Okay, everybody?
Yes, ma'am.
Need to test, you need to set t-test for each of the coefficient. T1, please write down the value of T1. It will be beta 1 hat divided by standard error of beta 1 hat. Beta 1 hat divided by standard error of beta 1 hat. Now, Shreya, what is the value of beta 1 hat?
2.20.
Beta 1 hat is 2.20.
No, ma'am, it's 0.104.
0.104, and what is the standard error?
0.005.
0.005. So you need to find out only 0.104 divided by 0.005. So what is the value of T1?
20.8.
20.8. Others?
Yes, 20.8.
I'm 20.8.
20.8. Then
Yes, ma'am.
please let's consider the tests at 5% level of significance. And let's consider two-tailed tests. Okay. So what will be the relevant t statistic with which we will compare the estimated t value? That will be, look at the right hand side, that will be t 0.025, because you are considering not equal to in the alternative specification. So it is t 0.025, and you have 76 observations, and you have 4 parameters in the model: beta naught, beta 1, beta 2, beta 3. So 76 minus 4, that is 72, will be the degrees of freedom. So you need to compare, the estimated value should be compared with the tabular value t 0.025 72, which is 1.99. Okay. Now, since this particular t-value is very, very greater than 3, actually we do not need to compare it with the tabular value. Directly we can claim that, what we will claim?
Rejected.
Yeah. Reject H naught at 5% level of significance. Next, in the similar manner, very first, please derive T2 and T3.
And the absolute value of T2 is 1.5.
1.5 or I'm writing the actual value. I'm not writing the absolute value. However, when we will compare with the tabular value, naturally we have to consider the absolute value. So please check whether you are getting this value. And what is T3?
I'm 2.26.
2.26. So tabular value is 1.99. So what will happen regarding beta 2? For beta 2, we will reject or accept H naught?
Accept.
Accept.
Accept H naught. And for beta 3?
Reject.
Reject. So first part done. Write down the second part. Is there anyone who didn't understand the first part? So we are finding beta 2 is statistically insignificant. Beta 1 hat and beta 3 hat, these are statistically significant. So B part, calculate the coefficient of determination. Calculate the coefficient of determination. Now, what is coefficient of determination?
Yes, yes.
It is the measure of goodness of fit. Coefficient of determination is the measure of goodness of fit, and therefore it is multiple R square, which is equal to ESS by TSS. So please note down that. So you have the value for ESS and RSS here. So please calculate R square first and tell me what is the value. The value of ESS is given. Tuba, tell me how we will find out TSS?
Ma'am, TSS is equals to RSS plus ESS from
RSS
there.
plus ESS. Very good. In the denominator, you have to write down ESS plus RSS. So numerator is ESS, denominator is ESS plus RSS. And then tell me what is the value for R square. Once you get it, please let me know.
0.85.
0.85. In fact, I think 0.86. It will be 0.8557, isn't it?
Yes, ma'am.
So it is better to report as 0.86. So everybody, please check this. Is there anyone who could not understand or has some problem? So let me move to part C. I hope by this time everybody could complete the calculation. It is 0.86. So let me move to C part. When, please write down, when three seasonal dummy variables were added, and the equation was re-estimated, the explained sum of squares, the ESS rises to 114.8. ESS rises to 114.8. And okay, this was only given. Test the presence of seasonality. Test the presence of seasonality. Test the presence of seasonality. Okay. So first rewrite the regression model if you incorporate three seasonal dummies. So please write down the given regression model can be presented as YT is equal to beta naught plus beta 1 x1t plus beta 2 x2t plus beta 3 x3t plus gamma 1 s1t plus gamma 2 s2t plus gamma 3 s3t plus vt. Now, why I am considering three seasonal dummies? Last day I discussed, if it is a dummy variable context and we have an intercept term, we have to use one dummy less. So if there are 4 seasons in a quarterly data, we have to incorporate 3 seasonal dummies. So the equation can be rewritten as this equation after incorporating the 3 seasonal dummies. After incorporating the 3 seasonal dummies, where S1t is equal to 1, for the first quarter, 0 otherwise. Similarly, please write down the meaning of S2t and S3t. Now, what is the implication of S2t, or what is the meaning of S2t?
uh, one for the second quarter or zero otherwise.
Yes. So it is 1 for the second quarter, 0 otherwise, and you are understanding how to write the third quarter. So this is the implication of or meaning of the 3 seasonal dummy variables. Okay. So you have to test for seasonality. So how you will write your null hypothesis? So what will be your null hypothesis? Question is you need to test for seasonality. Now tell me what will be your null hypothesis?
Gamma 1 plus gamma 1 equals to gamma 2 equals to gamma 3 equals to 0.
Yes. Or separately we can write the thing as
Beta naught minus beta 1 minus beta naught equals to 0.
no.
Sorry, beta 1 equals to beta naught, beta 2 equals to beta naught, and beta 3 equals to beta naught.
This is the null hypothesis. Gamma 1 is equal to 0, gamma 2 is equal to 0, gamma 3 is equal to 0. Okay? Or the way he said gamma 1 is equal to gamma 2 is equal to gamma 3 is equal to 0. Okay? Now when we get gamma 1 is equal to gamma 2 is equal to gamma 3 is equal to 0, are we getting back the original regression model? Yes or no?
Yes, ma'am.
Implementing this H naught, Choyan, are we getting back the original regression model? Choyan? Choyan is here, I think. Ritaja?
Yes, ma'am.
We are getting back or not?
Yes, ma'am. We are
Okay.
getting back.
Getting back. Okay. So can you tell me, so which model will be considered as the unrestricted model and which model will be considered as the restricted model? Ritaja?
ম্যাম যখন গামা 1 ইকুয়ালস টু 0, গামা 2 ইকুয়ালস টু 0, গামা 3 ইকুয়ালস টু 0 সেটা রেস্ট্রিক্টেড মডেল।
Very good.
আর যেটাতে ওই y ইকুয়ালস টু
restricted model.
Yes.
And the new equation will be the unrestricted model.
Yes, ma'am.
Okay, very good. I hope everybody is understanding this. So please write down. When H naught is introduced, we get the restricted model. We get the restricted model. And the model containing all seasonal dummies will be considered as the unrestricted model. Model containing all seasonal dummies will be considered as the unrestricted model. Okay. So I hope everybody is understanding we are moving towards F. So gamma 1 is equal to gamma 2 is equal to gamma 3 is equal to 0. That we will test using the F test, where the formula is RRSS minus URSS divided by restrictions
Ma'am,
yes.
ma'am, then the restricted model is the reference category.
Unrestricted model will be always the reference category. How the restricted model will be the reference category? With respect to the original one, you have to do these things. And reference category means what? I didn't get your point. You want to know it in terms of F statistic, or you want to know it in terms of dummy variable?
In terms of dummy variable.
In terms of dummy variable, fourth season is the reference season. When all S1T, S2T, S3T is equal to 0, that case, you know, we are getting the intercept beta naught, and that beta naught is the intercept for season 4, and that is the reference category if you consider in terms of dummy variables. Isn't it?
Yes, ma'am.
Yesterday we did this thing. And when we are writing the F statistic, if you say that with respect to what I'll compare with respect to URSS, because that is the original model. So I hope everybody is familiar with this F statistic. We used this F statistic, discussed about this F statistic, you know, several times. So it is RRSS minus URSS divided by restrictions divided by URSS by degrees of freedom. Now, what is 1 by 1? Tell me what will be RRSS here. So the original model is the restricted model. The new one is the unrestricted model. Okay. So what will be the RRSS? RSS of the new model or RSS of the old model?
The RSS of the old model.
RSS of the old model. Anyone will change the answer? So everybody is understanding these RSS 18.48 will be RRSS because we are considering the original model as the restricted model. So RRSS is 18.48. Now what is URSS? How we will get URSS?
Ma'am, URS is 13.28.
How we will get it? 13.28. First tell me.
Ma'am, the TSS remains constant,
You tell
but
the
the
formula.
ESS, ma'am, TSS minus the new ESS.
TSS minus new ESS. Very good.
Yes, ma'am.
What is TSS?
128.08.
128.08. Yes.
Minus
Yeah.
114.8.
Minus the new ESS. Now, how many restrictions are there?
4.
Not 4. Look at H naught.
3 restrictions.
3 restrictions, ma'am.
Okay. So 128.115.8. What is this value? This will again come in the denominator. So Rudra, this time, what is the value?
13.28 divided by
13.28. And the degrees of freedom is n minus k. What is this degrees of freedom?
76 minus 3, 73.
76 minus 3. Anyone will like to change the answer?
Ma'am, 2K, sorry ma'am, 76.
Rudra is telling 76 minus 3 will be the degrees of freedom of the URSS. Shubhangi, is it right? Shubhangi,
Yes, ma'am.
what will be the freedom of the unrestricted model?
-3, I think.
So how many parameters are there in the unrestricted model, Shubhangi?
Ma'am, it should be 76 minus 4, right?
76 minus 4, Upali, why do you think so?
Ma'am, because if we consider the unrestricted model, then we have 4 parameters.
In unrestricted model, you have 4 parameters.
No, ma'am, in the restricted model. Sorry.
In the restricted model, you have 4 parameters. In the unrestricted model, how many parameters you have?
3.
What is your unrestricted equation? Would you please your unrestricted equation? Tuba? Yes?
Yes, ma'am.
What will be the number of parameters in the unrestricted model?
In the unrestricted model, ma'am, 3 parameters.
3 parameters. Everybody is getting 3 parameters in the unrestricted model. Is there anyone who is thinking that it will be not 3, it will be something else? Arjo?
Yes, ma'am. Ma'am,
How
it's
many
3, I
parameters
think.
you are finding in the unrestricted model?
Ma'am, it's 3, I think.
Ma'am, in the unrestricted model, we have beta naught, beta 1, beta 2, beta 3, and also gamma 1, gamma 2, gamma 3. So are we going to count that gamma 1, 2, 3 also?
If you do not count, in that case, you are getting the restricted model only. Therefore, I am repetitively asking, what is your unrestricted
Ma'am,
model?
it's 6.
There are 7 parameters in the unrestricted model. If I do not count, parameters, in that case, I'm talking about the unrestricted model only. If I talk about beta naught, beta 1, beta 2, beta 3, 4 parameters, I'm talking about restricted model. If and only if I talk about or if I incorporate gamma 1, gamma 2, gamma 3 along with beta naught, beta 1, beta 2, beta 3, I'm talking about the unrestricted model. So there are 7 parameters. There are 7 parameters are there in the unrestricted model. Okay. So why you are using so many imagination? Look at the equation and count the number of parameters. This is the easiest job. So you need to find out this value. Please find out this value. 18.48 minus 13.28 divided by 3. Denominator 13.28 divided by 69. So what you can do, numerator you can multiply by 69 and denominator you can multiply by 3. So who will get, this value for the first time? Please tell me what.
0.03
0.03.
minus much.
The total value, check everything and calculate the entire value and tell me.
6.7.
Ma'am, I think it's 9.
It's 9.
9.008.
I also got 9.006. I got this one. And this will be compared with which F value? What tabular F we need to consider? I'm considering one tilt test only. If we consider one tilt test at 5% level of significance, let's consider one tilt test at 5% level of significance. In that case, what F value we need to consider?
Ma'am, F369.
F 0.05, 369
Yes, ma'am.
is 2.74. So estimated value is 9. Tabular value is 2.74. So what we will do? Please reject H naught. So we will reject H naught. That means there is significant presence of seasonality in this case. There is significant presence of seasonality in this case. Part 4, D. Two further regressions. Based on the original specification.
Ma'am, to further, please repeat.
Two further regressions based on the original specification. Original specification means without seasonal dummy. Were computed for the subperiods 1958 quarter 1 to 1958 quarter 1 to 1968 quarter 4. And 1969 quarter 1 to 1976 quarter 4, sorry, 1976 quarter 4. So we are dividing the data into two sub-periods, 1958 quarter 1 to 1968 quarter 4 and 1969 quarter 1 to 1976 quarter 4. Yielding RSS of residual sum of squares of 9.32 and 7.46 respectively. 9.32 and 7.46 respectively. Test the following hypothesis. Number 1, the error variances are identical, the error variances are identical in the two subperiods. Error variances are identical in the two subperiods. Number two, the coefficients are identical in the two subperiods. The coefficients are identical in the two subperiods. Okay, so both the tests are basically related to Chow test. The first one is one of the assumptions, testing one of the assumptions of the Chow test. That is when we consider the cross-equational restrictions, we need that the variances across different periods will remain unchanged. Okay, so we have first period, we have second period, because we have broken the entire data into two sub-periods. So actually sigma 1 square is equal to sigma 2 square. Sigma square of the first period is equal to sigma square of the second period. This is one of the most important assumptions of when we go for pooling and we go for Chow test. Okay. Okay, so this assumption, sigma A square is equal to sigma B square, homoscedasticity across different groups. So first test is basically related to this assumption, test that really whether there is homoscedasticity across two different periods or not. This is the first part of the question. And second part is the coefficients are identical in the two sub-periods. Okay. So this is this hypothesis. Alpha 1 is equal to alpha 2, beta 1 is equal to beta 2, gamma 1 is equal to gamma 2, delta 1 is equal to delta 2, this kind of test. So we need to test this assumption of the Chow test, and then we really need to run the Chow test to understand whether the coefficients are identical in the two sub-periods or not. So this is a stability analysis related question. Okay, so to proceed, we will first write down the number of observations N1 and N2 for the two sub-periods, and we will write down the regression equations for the two sub-periods. Okay, so please write down, let N1 be the observations for the first period, or please write down, let N1 and N2 be the observations for the first and second periods respectively. Just a minute. And find out the observations. Hello? So what is the value of N1 and what is the value of N2?
N1 equal to 44 and N2 equal to 32.
Very good. And we are writing two regression models. So please write down the regression for the two sub-periods are given by and that for the second So for the first question, we will write the null hypothesis as okay, whether the variances of the two sub-periods are equal or not. So this can be tested using sigma u prime hat square divided by sigma u double prime hat square, provided that the ratio is greater than 1. If it is a fraction, you have to consider the reverse ratio following the rule of F statistic. Okay. So we are starting with this. If we find this is greater than 1, we will proceed. Otherwise, we will consider the reverse ratio. That is, we will consider sigma u hat this we will consider. Okay. This we will consider. Now, what is the value of sigma u hat prime square? How we will calculate this? What is the formula for SU square?
RSS by n minus degrees of freedom.
RSS by degrees of freedom. So sigma u hat square, I hope everybody is understanding the estimated value, that is the sample variance. Okay, so it will be RSS 1 divided by N1 minus K. This will be RSS of the second model. So what is RSS 1? In the problem it is given
9.32.
9.32. And what is N1?
44.
So it is 44 minus, how many parameters are there in the regression model, in the first regression model? Huh?
4.
So this will be the value, and what will be the, what is this one? What is RSS2?
7.46.
And what is number of observations?
32.
So what are the values? Is it 0.233?
Yes, ma'am.
So consider the ratio. And check whether it is greater than 1 or not. What is the value?
0.86.
So it is less than 1. So actually we need to consider, hence the F statistic which we will use here, that is given by which is
1.141.
Okay, so we will work with this F statistic. So F value is 1.414. Okay, and the tabular value we need to consider is F 0.05, because we are considering the test at 5% level of significance. And you know, what will be the degrees of freedom here? Degrees of freedom of sigma u hat square, because that is in the numerator. Sorry, sigma u hat double square, that is 28. This tabular value we need to consider, and this is 1.74. Sorry, 1.74. Okay, your calculated value is 1.14. So are we going to accept H naught or reject H naught?
Accept.
So accept H naught. So we are accepting this. That means the assumption of the Chow test is satisfied. Okay. So the first part is complete. The second part. Is it okay to anyone? Everyone? Because I'll remove this page. I'll go for the next page, a new page. Okay. So the second part was The coefficients are identical between the two subperiods. So basically what I mentioned, I have to write the assumption of the chow test. So this is the null hypothesis. Okay. So you have to find out the value of RSSP these two values you need to find out. This RSSP will be treated as RRSS and this will be treated as URSS while you will write the formula for chow test. So first tell me how you will get RSSP or what is RSSP?
18.48.
Yes, 18. How you are telling that it is 18.48? Would you please explain?
Because the restricted model RSS is 18.48.
Yes. The original model is basically the pooled model will be treated as the pooled model because that is based on all observations. Very good. So for that model, it is given that RSS is 18.48. So RSSP is 18.48. Now what is RSS1 plus RSS2?
16.7.
9.32 plus 7.46.
Yes. 9.32 plus 7.46. So it is equal to 16.78. Okay. So now we will go for the F test. The formula is RRSS minus URSS. So here we will write RSSP minus what is the number of restrictions here?
4.
What will be the degrees of freedom here?
68.
Plus into minus 2k. Yeah, somebody told me the value.
68.
68. So this is N1 plus N2 minus 2k. So calculate the value and tell me what is the value. And this should be compared with the tabular value.
Ma'am, F equals to 1.722.
1.7. So what will be the final decision? Reject or accept?
Accept.
Accept.
Accept H naught. Everybody?
Yes, ma'am.
Okay. So the model is stable across 2 subperiods. So in this way, we can do problems related to dummy variables, related to chow test, etc. I told you to check 4.1. I'm reading the question, you know, Johnston is with you. So I hope everybody has. Before moving to that, is there anyone who has any doubt regarding this part? So I'm moving to 4.1. A bivariate regression is fitted to 20 sample observations on Y and X, where the data are expressed as, they have the database, you know, X prime X is equal to 30, 10, 10, 30. Remember, here we are running bivariate regression. That means Y on X. It is a 2 variable structure. And X prime X is given as 20, 10, 10, 30. X prime Y is given as 30, 40. Y prime Y is 75. A new observation is obtained showing X is equal to 2 and Y is equal to 4. Calculate a chow test for parameter constancy in these data. X prime X is given, X prime Y is given, Y prime Y is given. First of all, you have to calculate the parameters of the model, you know. Actually there is a single regression coefficient, so single slope term. So you have 2 parameters, the intercept term and the slope term. So you have to find out the intercept and the slope with the original data, and then you have to incorporate the observation X is equal to 2, Y is equal to 4, and recalculate the estimated parameters of the model. So you will have 2 sets of intercept as well as the slope coefficients. One model without this new information, one model with this new information. And then you need to run the chow test for this model. Okay, so this is 4.1, and I told you to do, I think 4.8. 4.8 is annual data 1929 to 1967. 39 observations are obtained on Q, L and K. Q is an estimate related to output. L is the index of labor input. K is the index of capital input. So you have 3 equations. Log Q is equal to an estimated model, R square and S values are given. Then the regression is there for the 2 subperiods. Similar kind of models are given for the 2 subperiods. And you have to test for the stability of the production function over the 2 subperiods. So this problem is very, very similar to the one we have solved. We have 2 subperiods, we have a pooled date regression. So, you know, however, the information is not given in terms of RSS, ESS, etc. Rather, information is given in terms of R square. Okay, and there are the A's values too. Okay, that is SU value. SU values are there for each of the models. So on the basis of, you know, so you have to make a twist for the last one, you know, since the information is in terms of R square, not directly in terms of ESS, TSS, etc. So you have to make just a little bit change and you will be able to do that. I am adding one more problem, that is 4.9. In case of 4.9, you have information on urban area, rural area, and here also again a 2 variable kind of thing. The usual 2 variable linear regression model is postulated, and the sample of 20 observations is drawn from an urban area and another 10 observations from the rural area. So for urban 20 observations, for rural 10 observations, and you have x prime x, x prime y, y prime y, both for urban and rural. Test the hypothesis that the sample relationship holds in both urban and rural area. Suppose your x is income and y is consumption. So the question is whether marginal propensity to consume is identical and the starting point is identical in urban and rural areas. So this is the question. Okay. So this is quite similar to the first one, 4.1, where you are given a data matrix, and on the basis of that you have to make certain calculations, and then you need to run the chow test. Okay. So if you understand how to do 4.1, you will be able to understand how to proceed for 4.9. So is there anyone who tried 4.1 and got some results, or some query about 4.1? Is there anyone?
Ma'am, 4.1 I have done that. We have done the previous sum, no, that beta hat equals to x prime x inverse into x prime y.
Yes.
Ma'am, in that process I have done.
And you got the result?
No, ma'am, after that
You could
I didn't.
incorporate the additional information on x and y and then got the result? Nazma?
No, ma'am. No, ma'am.
I didn't get you.
No, ma'am. I was just proceeding like that, and after that I didn't.
Okay. Yes, you have to do the things. Now, Nazma, since you did this thing, would you tell me what is the first component in the x prime x matrix? What does it indicate?
Ma'am, sorry, repeat please.
There is x prime x matrix, isn't it?
Yes, ma'am.
What does the first component indicates in the x prime x matrix? It's a bivariate model. Therefore, I'm asking for. So you have the components, four components.
Yes, 20, 10, 10, 30.
I'm telling what is the meaning of this component, what it is. Anyone?
And the number of observations?
Number of observations. Yeah. So this is number of observations. So don't treat it as not. It is n. But it is a bivariate data. Okay. So Nazma, I think you didn't do it following this concept, isn't it?
Yes, ma'am.
Actually, from the matrix, you need to read what are the meanings of all four components. Okay. So if this is n, what is the meaning of these? What is the meaning of these? And what is the meaning of this? These two things will be identical because it is symmetric matrix. So what are the meanings of this thing? That you need to understand. Otherwise, you will be not able to incorporate the new observation and you will be not able to proceed further. Okay, so that is important. Okay. I'm just showing you the these are the information, and
And beta hat is coming to 1 and 1.
yeah, beta hat will come as 1, 1. Yes. So what is important? Read the meaning of these. Otherwise, you will be not able to incorporate this. You will be able to calculate this. Nazma, you did it in following this formula, and you have to do this. You will get these values. Okay. However, read the matrix properly. This x prime x, x prime y, y prime y, so that you can incorporate the information that a new observation has been incorporated in terms of x and y. So try these problems, try your best, so you will get the, I hope you will be able to do it. So all
Ma'am, the value of f is 0.16.
I didn't get you, Rudra.
Ma'am, the value of f statistic, ma'am, it coming to 0.16.
Okay, so that you need if statistic means, I didn't
Ma'am,
at
for the
which
chow
year?
Chow test one, yeah.
আরেকবার বলো, without?
Ma'am, we have to test for the we have to calculate the chow test, ma'am. So
Yeah.
the value of f is coming to 0.16.
0.16 একটু দেখে নি, এখানে তো একটু আলাদা এসেছে। Here, this particular student has used the chow test 2 formula. I think you are using the chow test 1 formula. Therefore, you are getting two difference.
Yes, I'm using chow test 1 formula.
Yeah. Here you can use chow test 2 formula, because if you look at the chow test analysis, if number of observation is less than number of parameters, in that case, it will happen number of observations will be greater than.
But in this case, the number of observation is greater than the number of parameters.
না, তুমি তো একটা সিঙ্গেল অবজারভেশন ঢোকালে এখানে।
Oh, sorry.
তাই না? সেকেন্ড অবজারভেশনটা তো একটা সিঙ্গেল অবজারভেশন, a single value of x and y. Isn't it?
Yes, ma'am.
So it is better to use chow test 2. So we can use the predictive test of stability here. Okay, so I'll request all of you to do the, problem, etc., so that we can, if anyone has any difficulty in understanding the matter, we can discuss it. So our dummy variable and multiple analysis on multiple regression, this part is complete. Next, we have to go for regression diagnostics, as I mentioned. Okay. And yesterday I mentioned about the fact that we need to look at the X matrix. Is there any problem regarding X matrix? And we need to check what are the real properties of U in this section. Okay. So when we will talk about X matrix, please go through it. I have an important phone call. I need to. Okay, so we are talking about there are several regression diagnostics related discussion regarding X. Among these, an important discussion is regarding the omitted variable bias. If there is omission of relevant explanatory variable, whether their bias arises or not. From yesterday's discussion, I understood many of you did these things. However, maybe the understanding is not that clear, that you have to, go through and clear everything, and you have to understand the issues related to omitted variables, related to inclusion of irrelevant variables. This you need to understand. And there are some students, who didn't go through these kind of discussion. Okay, so for both the groups, I'm telling that at this level, at the postgraduate level, you need to understand the regression diagnostics very well, because you need to run several tests to understand whether there is any omitted variable bias, etc., before running the regression. So you need to do a lot of data management. As student of applied economics, you need to understand, a lot of data management before running the regression. Okay, so you need to clean the data. Okay, so let's start with the omission of an important variable. To understand the context, we are starting with a very simple model. Yt is equal to beta 1 plus beta 2 x2t plus beta 3 x3t plus ut. This is the true model. However, we are estimating the relation using a single explanatory variable x2t, say. So suppose this is a demand equation. Both price and income, these two variables have immense impact on the demand. However, we didn't understand it, or we couldn't collect the data on income, and we are considering only the price. X2t is the price. The consequence of these misspecifications are as follows. If an independent variable whose true regression coefficient is non-zero is excluded from the model, true regression coefficients, that means beta 3, is non-zero, is excluded from the model, the estimated values of all other regression coefficients will be biased unless the excluded variable is uncorrelated with every included variable. So what I am telling that, if I drop x3t, very important variable, from the regression because of some problem, in that case, all the other values, other estimated values, that will be biased. That is beta 1 hat, beta 2 hat, these two estimators will be biased. However, if there is no correlation between x3t and x2t, in that case, there will be no problem with the estimated values of beta 1 hat, beta 2 hat. However, while we discussed the ethics of multiple regression, we mentioned that when we consider a set of variables, there will be some degree of association, and therefore we get positive partial correlations, given others, this variable is telling this thing new about the variation in y. That means there is some sort of integration among the set of variables. Why in the demand equation we consider price of the related goods, income, etc.? Because theoretically the thing has been modeled in this way. These are related information. Okay, taste and preference, geography, etc. So typical set of explanatory variables we will consider. That means there is some degree of association between the two, between all explanatory variables. However, if there is no, in that case, if you drop an important variable 2, then also your estimators will be not biased. So this sentence is very important and we need to prove this. Even if this condition is met, that is, there is no correlation at all among the x variables, the estimated constant term is generally biased and hence forecasts will also be biased. So, if x2t and x3t are totally unrelated, in that case, it is found that beta 2 will be unbiased. However, beta 1 will be biased, okay? Constant term will be biased. So this also we need to check. The estimated variance of the regression coefficient of an included variable will generally be biased and hence tests of hypothesis are invalid. Okay. So not only regarding the estimated values of the parameters, we are telling that standard errors of the estimated parameters that will be either overestimated or underestimated, and naturally the t statistic, which is beta hat divided by standard error of beta hat, if both numerator and denominators reflect biased values, naturally any t statistic will be erroneous, any conclusion based on that t statistic will be problematic. Okay, so these are the serious problems if we omit an important explanatory variables. Now, if the true model is this and we present the model in this format, Vt is equal to beta 3 xt plus ut. Vt is equal to beta 3 xt plus ut. Okay, so this is that. The expected value of the error term, expectation of Vt in that case, is expectation of beta 3 x3t plus expectation of ut. Expectation of ut is equal to 0. So expectation of beta 3 x3t is beta 3 x3t because we are considering non-stochastic x3t. So we are not finding expectation of Vt to be equal to 0. So from the very beginning of the assumptions of the error term, we are getting some disturbance. The error is no more unbiased. The error of the second model is no more unbiased. Okay, so thus Vt violates the assumption of unbiasedness of error term in a classical model. More seriously, the covariance between x2t and Vt is given by covariance between x2t and Vt. So cov x2t, Vt is beta 3 x3t plus ut. So if I proceed, I'm getting this is equal to beta 3 covariance x2t x3t plus covariance x2t ut. So this can be simplified as beta 3 covariance x2t x3t as, by assumption, x2t and ut are not related. One of the most important assumptions of the two variable model or its extension is that there should not be any correlation between the explanatory variables and the error term. So when we are explicitly writing the formula, we are finding this part is equal to 0. So covariance x2t Vt, that is equal to beta 3 covariance between x2t and x3t. So once again, we are finding violation of assumption of the classical model. First, we got expectation of Vt is not equal to 0. Again, we are finding covariance between x2t and Vt. That is, in the second model, the covariance between the explanatory variable and the error, that is also non-zero. This is violation of another assumption in the classical model. Okay. So unless covariance between x2t and x3t is equal to 0, that is no relation between x2t and x3t, we will be not able to establish covariance x2t vt is equal to 0. So unless the covariance between x2t, x3t is 0, that is unless x2t, x3t are uncorrelated, the covariance between x2 and v will not be 0, thus violating the assumption of 0 covariance between explanatory variable and the error term in the classical model. Thus beta 2 hat will no longer be an unbiased estimator of beta 2. More formally, if I calculate everything, these are the two models. Beta 2 hat, if I consider this simple model, that will be summation xi yi divided by summation xi square formula. Okay. And beta 1 hat, that will be y bar minus beta 2 hat x2 bar. Now, if you calculate expectation of beta 2 hat, you have to calculate expectation of summation x2t yt 1 by summation x2t square. You can keep outside the range of expectation as x is non-random. So to calculate the expectation of the numerator, we are considering summation x2t yt, that we are expanding yt minus y bar into x2t minus x2 bar. After adjustment, we are getting this value to be summation yt into x2t minus x2 bar. Substituting yt from the true model, we get yt from the true model means this model, the model having 2 regression coefficients. Okay, so check all these calculations. Summation yt x2t into x2 bar, we are getting this value. From the second term, we are getting this value to be this. So we proceed in the similar way, and finally we get expectation of beta 2 hat is equal to beta 2 plus something. So we are getting beta 2 hat is not an unbiased estimator of beta 2. So in context of omitted variable, while we are losing some properties of the classical error, we are finding that beta 2 hat OLS is no longer an unbiased estimator of beta 2. Rather, we are getting it is beta 2 plus something. Since beta 3 not equal to 0, beta 2 hat will be biased unless, multiplication of these two is 0. That is unless x2t and x3t are uncorrelated. Now the numerator will be 0 if x2t and x3t are uncorrelated. Okay. So unless x2t and x3t are unrelated, beta 2 hat is no longer an unbiased estimator of beta 2. Thus, the omitted variable bias is given by this second part. This is the bias of the estimated value. The direction of the bias, that is, if there is overestimate, underestimate, will depend on the signs of beta 3 and the signs of correlations between x2t and x3t. Note that beta 2 hat includes a term involving beta 3 in the bias part, which is the effect of the omitted variable, and hence we cannot interpret beta 2 hat as the marginal effect of x2 alone. Okay. Now, generally what we consider, what is the meaning of all these regression coefficients? Beta 2 hat indicates change in partial change in y due to partial change in x2. Now we are telling that beta 2 hat carries information on beta 3. So we cannot say that it is giving the marginal relation between y and x. As the sample size increases indefinitely, beta 2 hat will not converge to beta 2. So it is not that the bias is not that, or the value of the bias is not that. If we increase the number of observations, if n is increased towards infinity, you know, this will vanish. No, it's not happening. Okay. Hence, the estimator is also not consistent. So it is biased in case of finite sample. It is inconsistent in case of large sample. Next, we consider the intercept term. Intercept term beta 1 hat is equal to y bar minus beta 2 hat x2 bar. Hence, expectation of beta 1 hat is equal to expectation of y bar into y bar minus x2 bar into expectation of beta 2 hat. Okay, from this formula. Now, again, if you look at the calculation, if you do it step by step, you will find that expectation of beta 1 hat is equal to beta 1 plus this big factor, beta 3 into this big factor. Okay. So the necessary and sufficient conditions for beta 1 hat to be an unbiased estimator of beta 1 is this total part will be equal to 0. Here, x2 and x3 being uncorrelated is not sufficient to guarantee the unbiasedness of the estimate of the intercept term. So let's look at the thing. If you consider there is no correlation between x2t and x3t, this second part will vanish. However, the first part is there. Okay. In addition, the mean of x3 must be 0. That is, if x3 bar is equal to 0 and there is no correlation between x2 and x3, then only beta 1 hat will be unbiased estimator of beta 1. So these are the, you know, only the imaginary situation. So why the mean of x3 will be equal to 0, you know? So this is not possible. So generally, even if the regression coefficient or the slope coefficient or the gradient is unbiased, then also you will find the intercept is biased. Okay. So in this way, we can show that in presence of omitted variable, all the estimators will be biased. Okay. The danger of omitting a constant term in a regression model. If a constant term, it's a note. If a constant term is omitted, then the regression line would have been forced through the origin, which might be a serious misspecification. So generally, when you will proceed with your applied courses and you will try to develop your empirical research, remember that generally we will fit a model with the intercept term. Because under many circumstances, otherwise, that will be a serious misspecification by itself. The model will, the true model is actually not passing through the origin. Okay. So in general, you should keep the constant term in the model. Now, in the similar fashion, we can do the reverse. That is inclusion of the irrelevant variables, you know. In that case, your true model will be the true variable model, and erroneously you estimated this model. Just the reverse. True model is the model with lesser explanatory variables. However, you are incorporating a number of information here. The consequence of this misspecification are as follows. If an independent variable whose true regression coefficient is 0 is included in the model, the estimated values of all other regression coefficients will still be unbiased and consistent. Okay. So unlike the previous one, when we are omitting a variable, all the estimated parameters become biased. Here, if you put more information, you will find that estimated values are unbiased and consistent. Their variance, however, will be higher than without the irrelevant variable, and hence the coefficients will be inefficient. So here, the main issue will be the variance-covariance matrix of the estimated coefficients. Estimated values will still remain unbiased. However, the main problem is regarding the variance covariances. Okay. In the first case, I didn't do anything regarding the variance covariance. Actually, I'll do the variance covariance part in the second case, so that you can apply the same states and you can find the variances of beta 2 hat for the omitted variable part. Okay, so here you will find that I actually calculated the variances of beta 2 hat, and if you understand these calculations, you will be able to do or repeat the similar exercise for the omitted variable case, and you will understand how the variance of beta 2 hat is something else rather than the variance of beta 2 hat that should be under a classical context. Okay, so today I'll stop here, okay, with the mainly with the omitted variable things. Okay, and I'll send you material on inclusion of irrelevant variable part. So go through it and check everything properly. Check whether you are not understand. The first part is understandable because the similar kind of thing just we did. Now concentrate on this variance covariance part and check whether these are understandable or not. And if you understand the states, apply the same method to the omitted variable case to calculate the variances. Okay, so I'll send you the note on this part. Okay, and from the video you will get the discussion on the omitted variable. So make a mix up between the two, and try to develop your own note. Any question? Is it understandable what you need to do, etc.?